Well, good. Hello, afternoon, people. It's noon, so it must be afternoon. Uh, I'm alone today. Mac is actually making money. The COVID crisis has kept him very, very busy, and Kelly is off working on the West Coast, uh, very hard. Uh, but we're here to do what I like to do, which is Riedel artist director logic programming, which is strangely enough, the way I occupy my time when I'm out doing an intercom show, as you may know, if you do intercom, after you get everything all set up and everything's running, there's not much to do except maybe read a book or do logic programming. Why not? Why not? So I want to thank Michael Mason from CP Communications for providing this artist node for me to demonstrate on. And went up and saw their new shop, really nice place. Glad to go there. Glad to get out of the house. Um, the we were able to recently start a patron, a donation system where you can make donations to our cause to help us offset the cost of doing this. We're now 64. This is our 64th show in about 79 days. And we've been the three of us have been paying for this ourselves, and we're perfectly glad to do this. I mean, the point is that the shows are free because we want to give out our knowledge about these things, and that's what it's all about, supporting the industry. Um, I will be answering questions, so obviously you can click on the question thing and you can. I'm alone, so I'm watching it, and I will have an inkling of what you're saying. And also in handouts, there's two things. There is a doc which all it has in it is a hyperlink to this actual artist director program that I'm using. If you have director and want to open it up, you can get there and download that. And there's also a PDF of all of the different logics with little simple descriptions of how they work. So I've got the director version 7.4 running right now. Just gonna check to make sure that the node is the same firmware. I'm gonna put it on the network, and it is connected now, as you see down here on the bottom. And let me move these errors out of the way. And we see right away there's a problem here because the firmware is too old or incompatible right here on this error message here. So I'm going to look at the firmware in the online view. Yep, 7.2, too old. So I'm going to go and open up my director file, go to 7.4, firmware package, start with the node, and open it and do the update on the node. Okay, close that. And the node is going to come back online in a second after it reboots. Now the node is at 7.4. And I'm going to update the clients, the cards in the frame. Clients, update. Firmware update successful. Can close this here, let it reboot one more time. Now my two cards, Bay 1 and Bay 2, are the right firmware version, and my node is the right firmware version. Okay. So I'm going to close this, and now we'll go open up our file. I built all of these logic uh, examples separately. I will show you how to build them um, as we go on. It's called Logic Demos. It's the file, and this is the link to that same Logic Demos file you'll find in the Word doc in the handouts. So we're going to go to the Logic screen. Let me pull this over a little bit further. And we're in the Logic screen. So I'm going to start right out with the simplest one in the Logic screen. Click on the destination, and you'll see right above here are all the different kinds of logic blocks you can use in your logic programming. And if you hover over them, it really explains what they are. Let me go here to 80%. That's a little bit better. So a straight through connection, when you create a logic program, you do two things. You create a destination, which is the red part, and you create a source, which is what you might put on a button on a panel or somewhere the input. So this is the input, this is the output. If I wanted to make this output do something, I would right click on it and add a function to it. All these items I can add to it. I could route audio, I switch to GPIO, make a light flash, all these different things, much like the controls you could put on an actual key, but not all of them. So that's a straight through. If we look at a couple of the logic ones here, destination for the not is basically the same as the straight through, but if I put a not in the middle, if I turn on the input, the output is off, and vice versa. And let me go online with this node here and turn this on. Now I can see that the output is green, and this is in the logic programming, you have a way of testing your logic. So I can actually put this on an actual key on a panel, and I can press it. So I'm pressing the key on the not where I thought I was doing. Oh, there it is, not on the not. So when I press the key, it goes on and the output goes off. I let go of the key. Now I'm not pressing the key and the output is off. So it does the opposite of what you actually put on the input. The next one would be OR, which takes two inputs, OR 1 and OR 2, and if either one is on, either one, this or that, the output will be live. So this or both of them, the output is live. And this is, you might want to use if you had several different conditions that you wanted the result to happen, whether or not they were on or off, right? And is very similar. Two different inputs and one output. Here's one input. I'll have to turn this on. Keep forgetting to do that. So here's one of them. There's one and here's the other and, but I need to turn them both on to get an output. So this and that gives me an output, right? Let me go down a little bit further here. Now NAND is basically and not. Here's an and, but it's got basically an inverter here, the same one as we spoke before on the second thing I showed you. So here, it's going to be this one on, or this one on, does nothing. The output is always going to be on. But if I turn both on, the output goes off. So in an AND, if you have two conditions that are true, the output is going to be off. Now you could build it a little bit differently. I could, let's say, take this, delete that logic line. I could delete this logic gate. I could use an AND here, and I could use an inverter over here. And I could put the inverter there and wire them together. So this goes to this, and this goes to this. And then that gives me my AND function. And then the NOT gives me my NOT function. And I send it to the frame. And now, when I press those buttons here, the NAND, here's that one on, here's this one on, both of them on, I get nothing out, just like I did before. Let's see if I can get rid of that annoying selected line there. Okay. So here, if we look at this as one unit, just like the NAND was, one on, nothing, one on, nothing. But the AND, if I turn it on, the AND puts out an output, but the invert inverts it. So now I get the same result as using a NAND gate. Saves putting up one gate on there. They could have saved and not built it, but it's often very useful. So NOR is very similar. NOR is an OR, but with a NOT at the end. So here's my NOR. Either this one or this one will turn off the output. This one, both of them, just one turns off the output. And you could do the same thing. You could build an OR gate plus an inverter would give you the same result. Exclusive OR is a little bit different. The exclusive OR will give you an output when there are no inputs. Let me just get the phrasing right here. Exclusive OR only returns a 1 if the two inputs are the same. So here's 1. Oh wait, why am I XOR? Where's my XOR? 1. Now when the two inputs are the same, it only returns an input if the two inputs are not the same. My mistake. So if I send an input into either one of them, it's like an OR. Either one will pass it straight through. But unlike an OR, it will only do it if the input is exclusive. It's only one of the two is on. If both of them are on, it turns off the output. Same with an exclusive NOR. Here. So 1 on turns it off. 2 on turns it off. 3 on, all 3 of them on, leaves it on. So here you only get, the output turns off only if only one of them is on. Here's 1 on, it turns it off. Here's 2 on, it turns it off. It's on right now, but I turn on both, and it stays on. Now we get into some of the more interesting devices and useful devices here. This is what's called the D flip-flop, and it is essentially could be called a memory cell because it remembers where you're at, what you did. When you enable the C input or the clock input, it will pass the D input to the output. If the C input is not enabled, the D won't do anything. So here is my D flip-flop. So I'm going to enable the D and nothing happens. But if the C is on and I turn on the D, it should go through. Why isn't it going through? Oh wait, D, and then I turn off the C. There we go. While the C, it's only on the turn off. Now, a lot of these flip-flops only activate on the release of a signal. So here, if I have a signal on C and D is off, when I let go of C, it will pass that D onto the Q. So often when I use a D flip-flop, I put an inverter in before it. So whatever the input coming in will invert, and automatically, when I press the button, it will turn off the C and therefore let the signal go through. This is also useful as a divide by 2 function, and I'll show you how that works. Mono flip-flop is, I think, one of the most useful ones they have because it basically is a one-shot. I'm going to go to the properties of this mono flip-flop here. So there's 2 things you can do in this mono flip-flop. You can set the duration of the time, and right now it's set for 3 seconds. And during those 3 seconds, well, let's look at what it does here. So here, there's that. So in the mono, there's my reset button. Here's my trigger button. Now I'm going to trigger the bottom one, just short trigger it. Now I'm going to get 3 seconds of the output being on. It's a little hard to see the way I have it set here. So if I make this 5,000 re-trigger, it makes it yellow. Now, when I trigger the input, I'm getting 5 seconds worth of that output. But if I trigger it again, now we're counting the 5 seconds. I'm going to trigger it again. We've restarted counting 5 seconds. Trigger it again. We've restarted counting 5 seconds. Trigger it again. Restarted. At any point, I can trigger the reset and turn it off. So a lot of times you get, let's say, a signal come in and you want to register it, but not, you want it to do something, but if it's left on, it will do the wrong thing. So a lot of times you want to have that as a timer. So let me go back here now. I want to touch base on one thing. This is a clock, which allows me to put, here's a clock that's just clicking along here. I can go to properties. Right now it's set for 1 second, but I can go from 125 milliseconds all the way up to 1 day. So that clock is what's making this sign down here in the video at the bottom run, the Lunch with Pete sign. That clock is making that step across that label there, and I'll show you how that's all done. That's all done. It's like about 20 different logic statements to make that happen. Now, a lot of times you want to know if something happened in your system when you walked away from it. So you want to have something that latches and remembers that something has happened. So here's a latch 12 triggering. I'm going to trigger it. Oh, latch reset. I want to do the reset. There. So my output is off there. Now, if I turn on this latch, trigger it, it just happens. Boop, it's done. It's going to turn on that latch, and that latch could be, that trigger could be that I've lost power somewhere, or that a UPS has gone down, or something like that. And I would want to know that when I came back in the morning. So this latch is going to stay on until I reset it. Now, this is a fairly complicated way to do a latch, and it uses these one shots and the inverters and exclusive ORs and the D flip flop. But let me show you a much simpler way, which is done by having the loop call itself. So here's a loop trigger, and I can trigger that loop like that, and now it's latched on and it will stay on. But if you notice, this loop destination and the loop input, in the loop destination here, it is calling itself as one of the functions. Now I could put other functions there, like beep my panel and flash a light or whatever, but the output of this function is calling itself. It's recursive. So when it's on, it's calling itself. That's going into an AND, which is going into here, and it's going into there, and it's forcing it to be on all the time. When I get into the loop reset, hit the loop reset, and that AND, because this minus this inverter here goes away, this can no longer be an AND, goes away, and it resets it. So obviously this is a way easier way to do it. Now, what I usually do is when I'm doing a large show and I have a lot of panels, in the error section up here, error, this little one here, this here, which is where to go. It's off screen right now, but normally it would display in that error here it is, the errors in the system. I'm only got one AC power plugged into my node, and I don't have autosave set up in the director, so it's giving me these two errors. But if I unplug I might go to my power monitor program here, power. This is the power monitor. It's inverting it, so normally it's getting a signal all the time. Now, one interesting thing about the panels in here, let me just show you on a panel here. Here's a panel that I have all my controls on. And if I go down to the bottom of this panel here, it's got some virtual functions. The always button, the always connection, is always logic positive when the panel is operating properly. Now you could send an piece of audio in there and have it always play into the panel. But as a logic function, it is always positive when the panel has its signal and its power. So what I've got is right on this, I've got the logic power you see on the Logic 18 power monitor. That's the program that I just showed you, the simple little going in, inverting, and coming out. And what it's actually queuing here on this other button on this video here, the PCOM button is the button on this panel. And when I unplug the power, I'm going to go here to the remote control so you can see it. I'm going to unplug the panel. I've unplugged the panel and I've made this thing start flashing right away. Now in the error alarms, it took about 5 seconds, but I also got an error that says panel offline, but there's no way to make that make noise. So this alarm here, I have a mute button. So when I put this on the panels, when I go away at nighttime, I can mute the beep. So any panel that went offline at any time during the night, I would see flashing just like that. Now and all I did was pick a marker signal and make it flash like that. So the places where I've used it the most, obviously, are on the larger shows where I might have 150 different panels, and I want to be able to know as soon as a panel goes offline so I can fix it, because more than likely the user is not going to notice it until they come back to their panel and it's not working. So I'd like to have this thing flashing. So what I do is I put that button, I make that button here. If I go over to the logic where I was talking about it before, to the this logic program down here, this panel power. So on this one right here, I've done a remote key on that panel, on my panel here, the 1028, show marker incoming beep. If I look at that, so here's my panel, standard page, the labeled PST, set the signaling marker to incoming beep, which is that yellow flashing beep. And then I've also simultaneously on here on this power, I have called beep Pete. And that beep Pete program is right here. And here's the beep Pete. And what it's doing, what this is doing, this timer is doing, it's every half a second, it's allowing the beep to go through. You know what the beep sounds like in panels normally? It goes beep boo, beep boo, beep boo, beep boo, very annoying. But if I just put this 1 second timer in, I can make the beep play any way I want to. So it can be a very much less annoying beep. Let me go ahead and put this beep Pete button on my other panel here. On my 1016. And we'll go back to logic here. And we'll find the beep Pete. Beep Pete, we'll put it right here. Now I can hit the beep Pete, which also I already had on that panel, and it's beeping on the other panel. We can go back to the logic. To the power control here. So there's the power which we did before, but the beep Pete is what we want here, beep Pete. And we look at this. So I press the beep Pete. It goes through the AND button, which is allowed because the beep mute button is inverted and always on, and then goes through another AND button. And every time the 1 second beep, this 1 second beep happens, it's a long beep. And what I do is I put it through a one shot here, and the one shot is only 200 milliseconds long. So I can go down, make it less, and the beep will be even less annoying. So I could even make it happen every 10 seconds. So you can customize the beep that's happening to you. Now, in this demo I just showed you, I did not use a latch to monitor my panel. And that being said, if the panel gets fixed before I get back to it, I won't know that. But let's say I wanted to use that latch. We'll go back up to that simple latch up here. This latch here. So I've got this programmed in there, but I want to make a new one for this panel. So I'm going to call this, I'm going to create a logic, and I'm going to create it in a destination number 2, in node 2. Every node handles the computational power of the logic, and there's a limited number of logic functions which you can put on a node. And if I look up here at help, well, I can't do that now, but there's a limited number, so you can spread it among all your different nodes if you have a lot of logic. So I'm going to call this panel power, lots of N's, and then I'm going to create an input, a source. It's going to be panel power. And then I'm going to make a reset. I'm going to use the regular reset on the system. So here, I'm going to now go down to my new panel here. So here's a new panel power monitor, and it's empty. There's nothing in here. But I want to copy the functionality of the loop, the loop one I showed you for the latches. So I'll go to the destination. I'll drag this loop destination on top of this new destination. And it says, do you want to replace the logic of the panel by the elements of 14 loop destinations? I'll say yes. So now it's copied this thing on my new destination here. And the loop function is already programmed into here like it was before, just like that. And the loop reset exists, but I want a different trigger for that. So that trigger wants to be the panel power trigger. So I'm going to drag this up there. So now I've got a new input, the same 14 reset, the same loop, and I'm going to send that. Actually, before I go do that, I'm going to go to my panel. This panel here. And I'm going to delete this function. And I'm going to put in that new function I just added, panel power source. Now I'm going to send all that in. So I'm going to take this inverter, because the output of my, come on, it's going to look a little messy, but it's the limitations of this system here. Put this in here, put this in here. I'm going to resend that. Also trigger beep. I wanted to trigger beep Pete. So logic, and then I add the beep Pete in there as a destination. So now this panel, when it goes live, when the panel goes dead, it will beep Pete. And I'm going to, there we go, that probably is it. So now my new There we go. Now, when I go back to this, it can get very complicated. When I go back to this panel power that I just created here, and I watch it. Now this is getting powered by my panel. And if I if I pull the plug on this panel, it sent the signal through. Now I'm going to replace the plug on my panel so the panel goes back live. Takes a second for it to boot up. Now the panel is booted up and you see it's back on here, but because I'm using the latch, this is going to continue flashing on my panel and beeping till I come back in the morning and I'm going to see it. So if I would normally, if I were doing real monitoring of panels, I'd want to know every single one that was out of work. Now I didn't program in this panel power the beep function, so the panel, so a remote key for this panel here for the 1028 for the button beep beep beatcom set to beep a port activated, and I send it. Now it's flashing that button on the PCOM. So now if I set loop reset, it does a reset there and I'm back to the start. So that's a very useful function, which I've used on a lot of shows, and it's particularly useful to keep an eye on the quality of the system. We did this same sort of loop test program on every UPS we had in the system in Beijing, and we had 16 different nodes out there, and some of the nodes were in closets down in the basement that were really with nobody near them. And every node had a panel in it, and we used a GPI input to the panel to basically trigger this function right here. So in the panel, if I go to a panel here, like this panel here, 1016, and go to the GPI and define a GPI as normally open, normal. Actually, I think we did it as inverted because we found it was more reliable to test whether or not a relay closed than whether or not it was closed, because the relay contacts were often not good. So then we put this same relay button here into a relay that was plugged into the power of the UPS. So as long as the UPS was powering the relay, its normally open contacts were closed, and their normally closed contacts were open, and we were sensing that the UPS was good. So what happened was the Chinese were very unsure. They wanted to check over the entire system and make sure it was all okay. And unbeknownst to me, they were doing a walkthrough of the entire system with our tech manager, and they got down to the basement into one of the rooms where the radio repeaters had some amplifiers, which fed all of the walkie-talkies in the tunnels through leaky coax. And they said, well, this is unattended. How do we know it's going to keep working or not? And the tech manager went in and he pulled the plug on the rack, and the UPS started beeping and said, well, yeah, that's fine, but in about 10-20 minutes it's going to go dead. Well, in the meantime, my panel started beeping at me madly. The power to the UPS was disconnected, And I got on the radio and I said, we lost power down in the radio room. And the Chinese said, oh, okay, somebody's paying attention to this. So now, nowadays, with UPSs, we have networked them all. So it's much easier to keep track of the UPSs. Let me look at a couple of the questions here. Mark says, when experimenting with logic files while the system is live, you can receive a config error. Yes, we definitely do. And you need to do a panel update can't merge to fix this logic. Quick save. Well, the first quick save is you may have done something, and that could be as simple as starting to program a key on your panel and then not finishing it. That's a function. Now, when I try to send this to the artist frame, it's giving me an error. The configuration contains errors. It cannot be sent. See the configuration errors window for detail. If I go to the configuration errors detail window, there's my error. And I can double click on this and see what needs to be programmed. Here, properties of key 7, shift page, panel 116 has a problem. So the easiest thing to do, I go back to that panel and kill it, and now I can send it. Same thing happens with logic. If I create a destination like this, but don't bother programming it anywhere. Here's my destination. It's sitting there. Nothing's been done. Or maybe I've done all the programming, but one of the leads, one of the wires is not connected. It's going to give me that same message. It's going to see the configuration error for Windows, and I go to the config error screen and I see, logic destination is empty. Logic's not connected. So I can look at it and it takes me right to that screen. I can see, okay, it's that logic to that destination. Go in here to wherever it is and delete that one item that hasn't been done. And then I can send this whole thing much better. Am I using a virtual PC? Yes, I'm using Parallels on my Mac. Director does not run on a Mac, only runs on a Windows. So that's why I have to run Parallels. Ryan, I am doing that. There we go. Mickey. Okay, all of these logic functions, Vinny, all of the logic functions have a destination. And when that destination in the logic function, you can add functions to it, like root audio, switch GPIO, remote key, which we'll get to a reason for that later on, and all these different things. So it is not just a root audio function, but we can do other functions. So I can beep a panel or clone an output port or dial a phone or actually call another logic function. So they're basically need to be programmed. Now I can program them over here by right-clicking and going to properties, but I can also do it in this screen right here, do the same thing. So another interesting control is for controlling your radios. Now in Beijing, we had a lot of semi-duplex radios where they had a separate radio transmitter, which would be keyed by pushing the button on a panel, and a separate radio receiver, which would play back the audio into the panels. And the reason we did that was so we could create antenna systems that fed a transmitter and antenna systems that fed a receiver. Now, there are other ways to do that. You could have a relay on the output of a simplex walkie-talkie. So it's getting, when it's in receive mode, it's getting the receive antennas, and when it's in transmit mode, it's going to the transmit antennas. But Riedel elected to do it the first way with 2 different devices. So in that system, we had plenty of analog ports. So we would just run the receive audio radio through an analog port that we would mute anytime we were transmitting. And the reason we wanted that is for the individual user on a panel would press a button to talk to a walkie-talkie, and without that mute function, he would get himself back out of his speaker at basically feedback levels. So we had to mute the receive radio. Well, a friend of mine who works on a lot of these shows with me, Radwan, came up with this method, and it's a much more efficient method. And it taught me a couple of things about the Riedel system that I totally baffled me up until that point. So let's look at an analog input. So this is basically the input you see for an analog input. Now you can assign up to 10 virtual keys to it. I've assigned 1 to it, but these 3 things, virtual functions, are sort of interesting. The Vox is logic positive when audio goes into this input. And the on-call is logic positive when audio comes out of this input, out of this device. So this device is a 4-wire port. So this goes positive when audio goes into that 4-wire port, and this goes positive when audio comes out of that 4-wire port. Now, if you notice, the audio out here does 2 things. It does radio PTT, and it's doing logic 17, which is panel audio, which means panel audio is coming out of this radio. This one up here is listening to radio audio. So the radio audio is going in here. So when radio audio is going in here, this is positive. And when people are talking on their panels, this is positive. And it's also pushing the GPIO push to talk so that their voice will go out the walkie-talkie. So what we did is, notice in these 2 things where you would normally feed in audio, let's say from a PL channel, instead of feeding the audio from the PL channel into this radio, we put a virtual key on it and put the party line for that radio channel on there. Now, virtual keys don't have a listen volume control. They basically are always listening all the time to a conference. So this conference was always feeding the input. It was always feeding, when this is pressed, the audio would go to this on call, and when this is just sitting there, it's listening to the Vox input from the radio. So I have I'm gonna turn this down here. I've got a ping noise generator right now, which is on. Here's coming into Vox here. Turn it off. There's no audio coming from the radio now. Then I turn it on to simulate audio coming from the radio. It's there. But if I talk on the radio, now I'm talking on the radio, you see they're both on. So now out the bottom here, we've got the, coming out the bottom right here, we've got my audio and the panel audio. So what we did is, in that logic, what Radwan figured out how to do in this logic, panel audio and radio audio are those 2 ports of the 4-wire input. So here's the radio audio coming in. I'm going to turn the radio audio off. Now, when the radio audio comes in, because of this inverter, it goes to the destination of this. And one of the things this destination does is push the talk key on the virtual key. So the radio audio coming in it goes in here, pushes the talk key, and therefore the radio audio is going to the party line for that radio. But when I talk on my radio channel, now I'm talking on the radio channel, my audio is going out to the transmitter, so it's muting the audio coming from the transmitter. So now, without wasting a whole analog port to mute something, we've done it just like that. The Cristobal asks, can you save your program logic to use in another configuration? Meaning, can you take the file that I've given you and load it into another show? Well, there are two different ways to do that. One is start with this file with the logic in it as your base file. Second way is merge this file with your existing file. And when you merge a file, it's up here in file up here, file, import, and you merge it in together. And it will ask you if you want to use put in a letter to put a prefix on everything you're merging, so there's no accidental creation of two inputs with the same name. But if you know that's not true, don't bother doing that. Just bypass that section. And then you can copy your favorite logic diagrams from that node into this node. So you create your destination in your real node, and you copy by dragging over the favorite logic you want from the other node into there and put your new panels on. So there is a whole video on my website, bestaudio.com, that goes through the copying of files, copying of logic files. It makes it much easier. There's also a detailed diagram about this particular functionality and the input-output functionality of the 4-wire ports. Let's see, how would the radio interface look if it was done with the analog audio on a panel and the second AS67 channel to the panel? Well, as far as this system is concerned, this node here could be AS67. It doesn't have to be 4-wire analog audio. This could be an AS67 panel. They look the same. Functionality, they are exactly the same for any 4-wire input-output panel. So it'd be exactly the same. If, by the way, if any of you have a function that you've wanted to do, bring it up, and I'll see if I can come up with a way for you to do it. Now, one of the ways that Mac has been using logic in some of his shows is he has a director who is colorblind, and therefore he can't really see what all of the LEDs are doing on his panel. So anytime he had the panel on, anytime he pushed the button and had the panel on, he wanted the button to flash. So let's see if we can figure out how to do that. So here in Logic, we're going to create a function, a destination called flash button. And then we're going to create a source called flash button. And we're going to go down to those buttons here. So here is, here's my flash button destination, and here's my flash button source. So this button will drag it on and stack it on the button that he's pressing a button on. And when he's pressing that button, we want to make the LEDs on that button flash to let him know that he has that button live. So it's not there's no logic really involved at all. We're just going to connect this to this. And then we're going to, in this button right here, let's use that same button I had on my panel. We're going to remote key onto the 1028, onto the, let's do key 8, 9, 10, and we're going to flash it with, let's say, the same beep flash we had before. Okay, now on that panel, we're going to wrong panel. This is that panel right 8, this is panel 10 or key 10 right here. I'm going to take the party line. I'm going to make a party line. And I'm going to put it on that key 10. So there's his production key, but he wants that to flash when he's got that on. And he's a stage manager, so he often can latch that on like that. So there's his latch key. The little L means that he can latch his key on. But what I'm going to also put on that key is that logic function, flash button. I'm going to drag it and put it on the same key. So if I hover over it, you see call to conference prod and logic flash button. So here, now we save it. We've got production on our panel down here. And when I push the button, we have to turn on the flash. So here, let me turn on flash. So I'm going to go up here to edit, marker definition, beep a port activated, and I'm going to flash it. So now when I turn on that key, it's live. That key is live. And when I turn off the key, it's off. So using that function, you can do some customized programs for a particular flashing information. There we are. Okay, so we're all caught up in questions. Now I want to show you what I did for a couple of different other shows. One was just to occupy the time during the show. And that was, how do you make words chase across your screen like this? How do you make those letters chase across the screen? Well, you can see the logic on the left. I've got 16 logic destinations. And each one of those logic destinations is a different display word on screen command. So for instance, if I go to the first one and I look at the function, it's a function called dot 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 L. So that's the first L that comes on the screen. So basically, I made 16 functions, and then I made the words jump across the screen. Well, if I go down a little bit further here to this, here is the way we control those 16 functions. So here's the basic clock. Math clock, clear, math clock, here. So here's two different things. This is called math clock clear. When I turn off the math clock, when I turn off the clock, it doesn't do what it's supposed to do. Why is it not doing that? Math clock clear. Set key text. Well, I'll have to look at that. But the second thing is math clock 0. So here's the basic clock. 500 milliseconds through an AND with the clock on button controlling it. And then it puts out on the output, it goes to math count 1. That's a logic. So if I look at math count 1, it's going straight through. Every time that clock clicks, it's sending it through. Now on math count 2, it's doing going to math count 2 and going math in 1. So math count 2 is dividing it by 2. Now this is one of those functions I said it's great to use for this D flip-flop. If you watch here carefully, it may go up to math count 4. It's a little easier to see. For every 2 inputs, the output changes. So what we've got is a 4-bit binary counter. And it's counting like this. All zeros, then 0001, then 0010, 0011. And the way we're determining that on this one that is 0011, if I look at the logic, it's looking at math in 1, 2, 3, and 4, and you can see these changing. All those these maths are changing according to the things, but some of them I'm looking for 2 zeros, and here I'm looking for 2 ones. So when it's got 2 zeros and 2 ones, I get the correct output. So it was a silly exercise, which is what I do when I'm sitting and bored back in the comms area. I have been caught during the show playing solitaire on my computer, I admit, by the technical manager of a show. And the picture was funny at the moment afterwards, but obviously I was a little embarrassed. I wasn't sitting and paying total attention to the show. So Marty came up with an idea. He says, here's a setup I have coming up at a client installation. They want a squawk box panel in the green room. We're using ClearBar KB701 with a 4-wire interface, and I have a 2318 panel to connect to get audio in and out of the green room box. Also need a GPIO output to dim the program audio in the monitor speaker. So I assume what you're saying is you want to push a button on your panel to talk out of this box, and you want to dim the program audio in the monitor speaker. I don't know why you need to use a GPIO output to do that, because you can do it without having a GPIO input. If I were to do that here, if I go into my network node here, and I'm going to create a split output here, and this is going to be output is going to go to my Clearcom dress channel, Clearcom dress channel out. Oh, he wants a 4-wire. My bad. So let's go back to a 4-wire here. So this is the Clearcom dress channel. So when we put this button on a panel and he talks on it, the output will go into the dressing room. And if the person in the dressing room talks on their KB701, you'll hear back from them. But we want to open this up, and I'm going to send in a program feed. First, I'm going to get a program feed here. We're going to do here a 4-wire split. I'm going to call this input here program. So there's your program, and I put program in there. Now I'm on this channel right here. I'm going to play the program into the always input. And when I'm feeding audio to places, I always use the always input, because if there's a quiet place in the audio or the music, the Vox input will mute it out. And if I look on this port right here, in the details, no, where is it here? Priority. Maybe you can't do it with that. I was thinking I could set the priorities different, because if I set the party line level at a higher priority, so this is going to be page dressing room. And this is going to be the panel here. I'm going to call the port priority paging to the dressing room channel. Now, because I've chosen a priority paging as opposed to standard, it is going to dim what's going to that channel. the program audio that's already going to that channel is going to be dimmed. And where that's controlled is in the here, if I go in the default settings, in call defaults, here we go. So anything that has a paging priority, it will dim anything lower than it, like standard, by 24 dB. So every time I talk to that dressing room, it will dim my audio 24 dB. Now, the one thing he wanted to do is, oh, he sent in another note. He says, okay, he doesn't run the program through the Squawk box, even though we figured out how to do it. He's running through a QAC system, and that's where the GPIO comes in. Well, that's fairly simple right there. So here, let's say, let's take our same party line we were doing to the page dressing room. This is now a PL to the dressing room where I can talk to them and listen to them. And I'm going to take a PL out, comes either on a panel or on the node. But let's say this panel, let's just for argument's sake, this panel is the closest location to where I could mute that audio out of the speaker. Or if I just, let's say I come out this panel on a GPIO and it feeds a relay that mutes that speaker. So here I can define the GPIO out, normally open. So this is going to be mute DR speaker. So now I've got a GPIO here, which is mute the speaker. And on this same page thing here, I'm going to add a function, switch GPIO out. And I'm going to put that GPIO on mute dressing room speaker on that. So now, when you press this page dressing room, it will also activate the GPIO out, which will mute your page feed on that speaker, and then you will talk to them. Now, the question is, when the person from the dressing room calls you back, you probably want to have that speaker muted also. So let's go back to the input where that's coming in. So that's coming in on here. So it's going to come in on here, this input dressing room channel. And audio from the outside world, in other words, audio from the ClearCom belt pack comes in the box. And I'm going to take this program feed out of here because we're not feeding it that way. So here's the audio that comes into this box, will be the port, the audio from the ClearCom KB701. So I'm going to put on this box right here, switch GPIO out. So anytime audio comes in that port from the dressing room, it will also mute the speaker. So when you push to talk in the dressing room and talk, it'll mute the speaker in the room. And then when audio goes out to the speaker, because of the button on my panel. Now let's say we wanted to make this universal for every panel on the system that has a page dressing room. So I can put on this button here the same thing, on call, switch GPIO out. So now mute dressing room speaker. Now any audio going out to the speaker box or coming back from the speaker box will trigger the GPIO out. And on this panel right here, I don't need to have a GPIO out mute speaker. I just need to have the call to conference page dressing room. So when I push this button, it's going to squirt out audio out that port, simultaneously triggering the GPIO. And when they talk on the dressing room back to me, it's going to trigger the GPIO again when they talk back. Now the Vox does have adjustments in it. I can look at the Vox here on this panel, and it has the threshold, the hold time, all three of these: threshold, off, on, etc. right there. So you can adjust it a little bit. If your signal is really loud, you can raise this up so it's not going to trigger until it's really loud. So that fixed that. What other question? Hear the green room. We got the same thing. They can hear the green room. And you got that set up there. Okay. Yeah, the Marty, the Vox will detect audio coming in, and on call detects audio going out. So the GPIOs can be put on both of those, either way. Any other questions? So pretty much we've covered all of the logic functions, and I showed you how to copy logic functions and how to move them from system to system. I think I talked about all the different logic functions: clock, clear, beep. Oh, there's one other little thing. I don't have it here to demonstrate, but on the Riedel panels that are the 1100 series panels that have that if you don't touch a button on them for a few minutes, they go to sleep. And the reason for doing that is because they have a limited number of activations before the OLED dies, like, you know, 1 million or something like that. But for those 1 or 2 clients that really hate that, you can use this circuit here. This circuit puts out a pulse every now and then. It doesn't have to be that fast. It can be really slow. I can set this to be 30 minutes. So here's a 30-minute pulse that's coming out of here. It's being changed to 100 milliseconds here as a one shot. And then I have also a button on my panel called Enable No Sleep. When this is on, the signal will go out to the panel. And on the panel, I found that 2 things will help. You can remote key onto that panel another button, push any button, or you can put a virtual key on that panel and remote key that button, and it will wake it up every now and then. So that's another cute little way of doing that thing. So that's pretty much it. If there's no more questions, Mark, you've been trying to figure out if there's a way to trigger logic by any key being pressed on a user's panel other than by dropping the function on every key. It depends. Like when I showed you that thing about the GPIO triggering another panel, that's done on the Firmware port. But let's say I was in a situation a couple of years ago where I had a stage manager and an assistant stage manager who sat next to each other. And they complained that when they're both talking on production, they're too loud to each other. So the simple solution is I can put a listen volume key on each of their panels. So assistant stage manager has a listen key to the stage manager, and the stage manager has a listen key to the assistant stage manager. And whichever, a listen key will, as you turn it down, will subtract that person from any party line that you're listening to. So you can turn down the volume of somebody in a particular party line by putting that person, having a listen key to that person on your panel and turning it down. Well, we didn't want to turn down the function for them on every single channel. We just wanted some of them. So we had to do that function in a logic, and we had to then drag the logic key to every single button on both panels where they shared a party line. Sometimes one or two of them didn't want to have it turned down, but most of them did want it turned down. So that is the only way. So that's the advantage also of logic, is you can drag and drop onto the panels. But how to do a function, other function, have to have more information on your question there. So you can use a logic function to switch an audio patch. Add select audio patch, and there you are. So that's all it is. It's just the function you put on there, select audio patch. So that's going to go in a particular panel. It's going to have a, I think on this panel I had a mute function here. No, not this panel. This one here I had a mute. No, I don't. I have no audio patches set up, but it is a function you can do on there, is select audio patches. Anybody have a send string function? It works with some of the Riedel equipment that does phone dialing, basically. So you can put in a phone number, and it will send a phone number to that unit. I don't have any of that equipment on here. The RCS is a particular panel that doesn't have buttons on it. So it's not a function that I've ever run across using. Is there an inhibit crosspoint function? Well, you can mute crosspoints, dim crosspoints, can do RMK, because the Riedel system, and certainly the Riedel system into a ClearCom system, doesn't have the function about RMK. But you probably could do a GPIO into an RMK in a Riedel panel. Well, Mark points out in the example with the listen key, yes, you have to listen to that panel all the time, but you're already listening to that person all the time, every time they talk. And that's why we had to put it in logic, because we only wanted that listen key to be activated when the other person was talking on a channel that they would have heard anyway, that we wanted to turn the volume down on. Any other questions? Anybody got any work out there? Well, I really, really appreciate being able to do this for you, because doing logic functions for me is one of the more fun things in there. And we're going to have a we're going to have a terrific show with ClearCom coming up in the next couple of days, um, also about logic functions. ClearCom on when is it? I have to look on a different schedule here. It's going to be in a couple of weeks, I think. Ron Rosenblum is going to come on, and he's going to do ClearCom relays, controls, and GPIOs on Monday, June 22nd. So that'll be basically all this same stuff, except in the ClearCom world. And interesting, the logic functions in all of the three major intercom systems, ClearCom, Riedel, and Atom, all have different ways of doing it, and all have some really powerful functions, but all can't do the same thing. So it depends on which system you're using. The other thing we have coming up Friday is a point source audio show, and we call it self-miking. Can this really be a thing? Well, that's basically what it's going to come out to after the COVID. Is we're going to have to find a way to go to the CEO and say, your mic and stuff is in that bag, it's all sterilized, we'll stand here while you put it on and help you fix it. So we'll sort of address that a little bit. And then on Monday, June 15th, we have a show from a group called I Need Space, which is an interesting group of people that have put together day-long musical events. Every hour on the hour, a different musician comes on and plays, and you can donate to them just like you can donate to us to help support what they do. And then on Wednesday, June 17th, we have a really exciting show, I think, because it's basically the two stage managers from the London Olympics are going to talk through how they called the entire show. In fact, they will play the entire show with their calling channel live, so you can hear all that was done. And I'll talk for a short period of time about the massive intercom system we use there with 150 panels and 180 belt packs, and it was a huge undertaking to make that system work. And then on Friday, June 19th, we're going to have a show called Shop Prep, where Ike Zimbel is going to tell about how do you come out and take your equipment and get it out of the shop, get it into your show. So again, thank you very much for listening to my show. I think that the key is Logic can do a lot of stuff, and I'd be glad to help anybody who wants to who has a problem with doing Logic. Just give me a call anytime, and I'll work out the problem with you. So I hope you have a nice day. It's beautiful and sunny out here in New York. I'm going to go for a walk. So see y'all later. Bye-bye.